Kirkman. All right, here we are on our third video for Module 12. We are now looking at additive relationships. So in the last lesson, we did multiplicative, where we were multiplying, and today we're going to do additive relationships, where we're going to add. So in today's lesson, you're going to identify a relationship as additive and represent it with equations, tables, and graphs. So just like before, here's a practice problem to get us thinking about additive relationships. Go ahead and give it a try. Pause the video and then come back and join us so that you can see what your answer is. So in this problem, it says in science class, students are measuring the mass of flasks with different amounts of liquid. Each flask weighs 40 grams when empty. That means that just the glass of the flask alone is 40 grams. Okay, no liquid inside, nothing inside, just the glass. Below are the various masses of each flask and the liquid inside. So this liquid right here is equal to the 40 grams of glass plus whatever the liquid is. So for every single one of these, we could write this equation and then solve to find what the liquid is. All right, so if I'm solving an equation like that, I'm basically going to just subtract. So liquid A is 20 grams. Liquid B, if I subtract, is 40 grams. And liquid C is 80 grams. Describe how you determine the number of grams of liquid. Well, we did the glass plus the liquid equals the total, and then we solved for the liquid and we subtracted. That's what we did. All of these equations that we wrote up here are additive equations because we are adding to get the answer. Okay. An additive relationship can be described by the equation y equals x plus m. Y is still representing the dependent variable. X is still representing the independent. And m is still representing our constant or our additive. What are we adding? Same thing, that m value always needs to remain the same in order for this to be considered an additive relationship. If things change and the number you're adding changes, it's not an additive relationship and we cannot use the equation y equals x plus m. So let's try it in a table. Okay, in the table we're going to say, okay, 0 plus what makes 3? Well, that's 3. Okay, does 3 plus 3 make 6? Yes. 4 plus 3 makes 7? Absolutely. 5 plus 3 make 8? 6 plus 3 make 9? Yepity. So that means our m is plus 3. And it is important for you to know that it is plus 3 because in an additive equation, you could have minus m and take away something. So it is a plus 3, a positive 3, which means my equation is y equals x plus 3. Just like that. Easy peasy, very similar to our last lesson, but we are dealing with addition and subtraction instead of multiplication. Go ahead and see if you can do this one on your own. Pause the video and join me for your answers. All right, you should have figured out that we are adding 7 every single time. So our m, our constant, is plus 7, and our equation is y equals x plus 7. All right, let's put this to use with a word problem here. The industrial tech teacher told his class to add 2 inches to the length of each student's project. Okay, so I think I can jump straight up to writing an equation here because I know that it's going to be y equals x and then something here. We are adding 2 inches to every project. So if my project is x, I'm then going to add 2, and that is my equation. The graph gives us our independent and dependent variables. So X is length of the original project, and Y equals the total length after adding 2. Our process is +2, so I'm going to do that all the way through. And we can pick whatever numbers we want on the bottom. We don't have to start at 1. We could go by 2s. Let's say 2, 4, 6, 8, and 10. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2, 8 plus 2, and 10 plus 2. Now we're going to graph our points. 2 and 2 is 4. 4 and 6. 6 and 8. Notice that our line isn't quite going as high up as it was with our multiplicatives. Our line is kind of flattening out a bit because I'm only going up by 2 each time. I'm not multiplying and making it much, much bigger. 8 plus 2 is 10, and 10 plus 2 is 12. Now let's see, could my project be 1.5 inches long? Could my project be 2.5 inches long? Absolutely. So in this case, we do want to connect with a line in our graph because I could have an original project at any starting length. In order to do this though, I need to know what is y when x is 0, because I need to know where my line is going to touch my graph on the y-axis here. Where am I going to hit y? Where am I going to start if x is 0? Well, we're going to just put it in our table and keep the same process. 0 plus 2 is 2. So if our project was 0, we're going to add 2, and that's going to be my starting line. So now I can take a straight edge and draw a line through those points. And that's it. On our next one, we have an equation we're starting with. So we're going to jump into our table. We know our process is plus 10 all the way down, and we're going to pick some numbers. Let's start with 0. And then let's keep our evens here. 2, 4, 6, 8. 0 plus 10 is 10. 2 plus 10 is 12. 14, 16, 18. This was x and this was y. Now we know what the numbers are going to be on our graph. So we do need to make sure that 0 is our very corner and our starting number. On the bottom, I can just go by 1s, even though I skip counted by 2s. Okay. And then on the sides, this is where it gets a little tricky because I cannot just skip count by 10s. All of my numbers are going to be in one little box. If I do 10, 20, they're all going to be right here, and that will make my graph really itty bitty. We don't want to do that. So instead, I'm going to have to skip count by a number so that I can get up here and be under 18, but I am not jumping from 0 to 10 and then only going up by 2s. Every box should be worth the same amount. So let's go ahead and skip count by 2s. 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, when I go to put my dots, I should be able to reach and fill in my graph. So 0, I'm going to do a different color so you can see my dots better. 0, 10 is my first dot. 2, 12 is my next. And then 4, 14, 6, 16, 8, 18. There we go. That is my graph. But now we have to fill in what's the point, what's going on here. So what is something that when I start with, I'm going to add 10 and get something else. One of the things that comes to mind is like fees or taxes. Fees are nice because fees are usually can be consistent. Something like let's see, if I'm purchasing, tickets. If I'm going to purchase tickets, this is the cost of the ticket, and then it's going to add $10. So this is going to be my total fee. Okay, so we'll say that there is a $10 fee on tickets online. So if, I mean, this is kind of silly, but if my tickets cost $8, then I would add the $10 fee and I'd have to pay $18. If we had come up with our description beforehand, we probably would have wanted to go by tens, you know, because tickets don't usually just cost $1. But we're going to keep it here because it still fits and it's okay. All right, one more. And here we have the graph that's given, and we have to fill in the rest here. So when they give us a graph, it's always best to just fill in the table first. This is going to be our original cost, and this is going to be our total cost. I got that from the graph. Then I'm going to find points on my graph. Okay, let's pick points that are easy to read here. So we can start with 50. When x is 50, y is 0. When x is 100, y is 50. Uh-oh, we're going down. We'll have to figure out what this process is. When x is 150, y is 100. When x is 200, y is 150. And when x is 250, y is 200. What is our process? How do I go from x to y? Well, it looks like we are getting rid of 50 every time. That means that my equation is going to be y equals x take away 50. Okay, well, let's think of a situation when you might have a cost and then you actually spend less than what it originally cost. I would say some sort of coupon would be working for this, something that would say you have a $50 off coupon to, I don't know, we'll say Target. Okay, so no matter what the price of her Target run is, or their Target run would be, they get $50 off. So they just lower their price by 50. So if they spend 50, they actually don't pay anything, which is nice. And that's pretty much it. So additive is very similar to multiplicative, but we're going to add or subtract instead of multiply or divide. Something else you might notice is that additive graphs always, they're not going to start at 0 for the most part, because when 0 is something, you're going to add or subtract something. So it's always going to be on the x or y axis. So that's a really good way to tell the difference between additives. See, here we started at 0, 10. Here we started at 0, 2, versus our multiplicative graphs, which always end up at 0, 0. Because if I buy 0 ice creams, I pay $0. Go to the next one. There we go. If I have 0 baskets, I have 0 oranges. If I have 0 time has passed, I've gone 0 miles. So multiplicative always goes through 0, 0, whereas additive does not. There you go.